let's take a look at Manitoba Pulse and Soybean Growers On-Farm Network 2023 trials and results and how they fit into the larger data sets. So in 2023, we had 56 trials in soybeans, peas, and dry bean crops. And they were across Manitoba, laid out on this map you have here before you. The background layer is our different ecoregions. So those are just areas of shared ecosystem and climatic traits, just to give us a little bit more background information for those areas. And we did have 12 different trial types or trial questions that we were looking to answer this year with our on-farm trials. So taking a closer look at those each different trial type here, we did have 38 soybean trials. Most popular trial types were soybean seeding rates, inoculant products and applications, as well as biological products, testing those out on farm through this network. And then for field peas, we had 13 trials. Most popular trial type was fungicide applications, most frequently comparing a single application at flowering versus none. And then seed treatment trials in peas were brand new this year. So we'll talk a little bit more about those. And then for dry bean trials, those largely did focus on nitrogen rates and inoculants. How can we really maximize nitrogen nutrition for this crop that doesn't really fix its own nitrogen, as well as our other pulse crops? So of those 56 trials we had in 2023, 5 of them saw significant yield responses to the different treatments we were testing out on farm. So that means 51 of those trials, we didn't actually see a yield response to whatever we were testing. This isn't necessarily a bad thing, because a lot of times that does mean we can maybe cut back on some input costs that we have on the farm. So those starred trials were the significant sites. 3 of those were pea fungicide trials, where a single foliar application versus none did improve yield by anywhere from 3 to 13 bushels per acre. Dry bean fungicide trial also saw a significant response, where a single application of Proline Gold at flowering improved black bean yields by 165 pounds per acre. And then we also saw a significant yield response to 15 versus 30-inch row widths, where the 15-inch row widths for soybeans did see a plus 3 bushels per acre versus the 30s. And we will talk a little bit more about some of those here. But before I get into that, I do want to touch on soybean seeding rates. So the pages in the corner of all these presentations, or all of these slides, that relates to the On-Farm Network booklet for this year. So if you do want to kind of dive into those summaries, you can find that booklet online here and turn to those pages. But we will start with our soybean seeding rate trials here, since it is our most popular trial type, which makes a lot of sense. This is a pretty steep investment cost for growing soybeans, that seed cost itself. And here in 2023, we did have 13 trials testing soybean seeding rates on farm, testing anywhere from 100 to 300,000 seeds per acre. Typically, we're testing 3 seeding rates, the farmer's normal practice, plus or minus 30,000 seeds per acre. So in 2023, we didn't see a significant yield response to any changes in soybean seeding rate. So what that kind of means is that each increase of those 30,000 seeds per acre did cost an extra $15 an acre. So we weren't really seeing that return on investment. Here's just an example trial. So this is soybean seeding rate 10, south of St. Malo. It just kind of looks like a soybean field maturing from above. So we'll add some trial boundaries here. These 2 dotted lines, those are the transects where we're doing data collection. You can see the holes from the late season plant counts right here. Each of those holes is 10 feet long. So we're cutting a representative transect across the field. So if we're seeing any differences between these treatments, we're really comparing apples to apples. This is hopefully quite representative and capturing a very similar kind of area of the field. So we are taking 2 plant counts at seeding rate trials, the first early in the season around V1, and then we're flagging and GPS those sites so we can revisit the exact same spot in the field later in the season towards harvest and measure that same area, so we can monitor and track if we're actually seeing any crop mortality throughout the growing season from the crop competing with itself and thinning itself out over time. So here, carrying on with this example, at this trial, we tested 120 versus 150 versus 180,000 seeds per acre. So that low seeding rate of 120,000 seeds per acre became 114,000 plants, yielded 60 bushels. 150,000 seeds became 142,000 plants, yielded 60 bushels. And 180,000 80,000 seeds became 157,000 plants and yielded 60 bushels as well. There were no yield impacts here. But what I do want to draw your attention to here is that difference between seeds to plants, where we've got 6,000 different seeds to plants at the low seeding rate, 8,000 difference at that medium seeding rate, and then at that higher seeding rate, we're seeing 23,000 seeds to plants difference with that higher seeding rates. We do tend to have lower percent establishment and more mortality throughout the growing season at these higher seeding rates. Getting into the graphs though, along the bottom here, we have different seeding rate ranges, each pair of bars increasing by 10,000 seeds per acre from 120 to 220,000 seeds per acre. And then what we're showing are the living plant stands throughout the growing season. So the left lighter colored bars is that early season plant count during vegetative stages or V stages. And then the darker colored bar on the right is that late, closer to harvest during R stages, that late season plant count. So on average in these trials, 81% of seeds actually established a living plant at early V stages, and 76% of those plants actually survived to harvest at R stages. So we are typically losing about 5% of plants from that crop competing with itself and thinning itself out throughout the growing season. Breaking that down a little bit more into chunks here, seeding rates of 120 to 140,000 seeds per acre on the left here. On average, we're seeing 86% establish and 3% of those plants dying off during the growing season. From 150 to 170,000, we're on average seeing 83% established with 4% dying off. 180 to 200,000 seeds, 80% establishment, 4% mortality, and then over 200,000 seeds per acre, that's really where we're starting to see it drop off with 77% establishment and 8% of those plants dying off during the growing season. So we really are typically seeing this lower percent establishment and more mortality as these seeding rates are increasing in the field. What does that mean for actual living plant stands that we're seeing in the field though? So from extensive small plot research in Manitoba, we do know that soybean yield is maximized at 140 to 160,000 living plants per acre. That's what's highlighted here in orange. So on average from our data, what we're seeing is that we need 170 to 190,000 seeds per acre to achieve that living plant stand. And then on the other hand, now highlighted in blue, 120 to 140,000 plants per acre is still within 95% of that maximum soybean yield. And we are consistently getting plant stands in that range with seeding rates of 150 to 160,000 seeds per acre. So we've kind of got this pretty wide range in seeding rates that's producing pretty acceptable plant stands and sort of similar yields within them. Now, same seeding rate range along the bottom, but these are the average yields for each of those treatments after several years of this trial and more than 120 on-farm trials. So there's really nothing much here emerging in terms of a yield response to seeding rate kind of relationship. So we can run multiple comparisons and we can say that this range of 150 to 190,000 seeds per acre has maintained yield while minimizing soybean seed cost. And this makes sense considering that these are those seeding rates that are getting us towards those target plant stands that we're aiming for. Highlighted now, these are the yield averages of those trials where we've got more than 20 on-farm trials contributing to that average. So we're pretty confident in these comparisons. So if we do compare these higher seeding rates of 150 to 190,000 seeds per acre to this lower seeding rate of 130,000 seeds per acre, if we're assuming that $68 per unit cost, $14 soybeans, which is a pretty conservative price right now, on average, we are seeing these yield increases large enough that they are going to more than pay for that increase in seed cost and improve profitability by anywhere from $20 to $80 per acre, with that greatest return occurring at 150,000 seeds and 180,000 seeds per acre. But over 120 trials in 12 years, 88% of the time, reducing those soybean seeding rates by 30,000 seeds per acre from your traditional practice has not significantly changed soybean yield in the on-farm network. However, thinking to that previous slide again, there is that return on investment to maintaining seeding rates above 150,000 seeds per acre. But to fine-tune this decision on your farm, evaluate living plant stands in every field every year. Are there areas on your farm where you can improve plant establishment of those seeds you're putting in the ground? It could be something like seed depth across the drill, residue management and distribution, soil temperatures and moisture at seeding, among all kinds of other things that you could definitely dive into and really maximize that plant establishment from the seeds you're actually putting in the ground. Moving to soybean row spacings, here is an aerial image of 15-inch versus 30-inch soybeans kind of early in July. You can see pretty big differences in the canopy closure here. So for soybean row spacings, we have two kind of trial types, narrow versus intermediate. Here, narrow rows are 7.5 to 10 inches, while intermediates are 15 to 20 inches. And then also intermediate versus wide, which so far have largely been 15-inch versus 30-inch rows. Typically for these trials, seeding rates are held the same for both row spacings tested. So we've got 10 trials of narrow versus intermediate and 11 trials of intermediate versus wide, with 1 trial of each in 2023. Looking at those 2023 trials a little bit more detail, SRS-01 towards Crystal City Clearwater compared 7.5 to 15-inch row widths, both seeded at 166,000 seeds per acre. And what we're seeing in the difference in living plant stands here is 33,000 more plants per acre did survive to harvest with the narrower row spacing. At this intermediate row width, we're starting to see a little bit of that crop competition within the row here. Though we had that difference in plant stand, we did not see any differences in yield, canopy cover, or weed densities when we were measuring weed densities at this trial. For SRS-02 towards Caterham, north of McGregor, comparing 15 inches to 30 inches, both planted at 140,000 seeds per acre. The plant stands that were emerging here, we did see 13,000 more plants per acre survive to harvest with that narrower intermediate row width of 15 inches, where we've got quite a few more plants here. And again, we're seeing that crop competition within the row with wider rows. As your rows are getting successively wider, there is more crowding within the row and the crop will start to thin itself out. Along with this increase in plants per acre, we also saw a positive yield increase with those 15-inch rows, increasing yield by 3 bushels per acre at this trial. Over the entire data set since 2019 for narrow versus intermediate rows, 40% of the time, those narrow rows have improved soybean yield versus the intermediate 15 to 20 inches, improving yield on average by 2 bushels per acre. Comparing 15 versus 30-inch rows at 11 trials, a less frequent yield response where 27% of the time that 15-inch row has improved soybean yield versus the 30s, but a larger yield response on average, improving yield by 3 bushels per acre. So these soybeans can be grown successfully at any row spacing. However, there is often a greater yield potential at those narrower row widths. There's also narrow rows do play a pretty big role in improving this crop's competitive ability, especially versus weeds. So they are also an important tool to mitigating herbicide-resistant weeds and their development on your farm. So recent research from Charles Geddes' lab looking at different integrated weed management tactics, just pulling out the narrow row work they did there in soybeans versus weeds. So narrow rows at less than 10 inches here did reduce weed biomass by 20%, improved soybean yield by 11%, and also reduced the percent of yield loss from competition with those weeds by 4%. And this isn't that surprising considering those ground cover benefits we have of narrow rows. So here are just snapshots from our on-farm trials this past year, looking at the amount of green versus ground visible in early July, just as the soybean crop was starting to flower. So our 7.5 and 15-inch rows already this early in the season, we've got more than 95% ground cover. The crop is capturing the majority of the sunlight coming through. Not a lot's getting down to the soil surface there where you've got late emerging weeds. 30-inch rows, on the other hand, there is still a lot of open space there, a lot of room for those late emerging weeds to really take advantage of and capture that sunlight. So we do just also have that better resource utilization in these narrow to intermediate row widths. Taking that one step further and looking at narrow row widths into the rest of your rotation, again, Charles Geddes' lab work here managing specifically glyphosate-resistant kochia in Western Canada. Here, they were using narrow row widths throughout the rotation to combat glyphosate-resistant kochia. So after 4 years already, they're seeing a pretty drastic decrease in both the amount of kochia reported as kochia densities and the size of those kochia plants. So that reduction in kochia biomass here, just by continuously using narrow row widths in all of your crops. So we're making that crop more competitive, and kochia is starting to lose a bit of its tumbleweed structure with that as well. If we also add in higher seeding rates, other integrated weed management tools, these numbers start to increase for how much we can really knock back this really aggressive weed. Let's move below ground now and talk inoculation strategies for soybeans. This is another very popular trial type. So these trials take on kind of two forms depending on your soybean history and what you're looking to evaluate on your farm. So the first is double versus single. So this is comparing two formulations or placements of inoculant. Most of the time in these trials, that's been a granular inoculant in furrow plus a liquid on seed versus single inoculant alone, which has typically been a liquid on seed alone. The single versus none trials is, again, a liquid on seed alone most of the time for the single, and then none is actually no inoculant applied at all that year for those soybeans. So these trials did start with double versus single in 2013. We had a little bit less quite a bit less soybean history at that time. Since then, those trials have really expanded westward and into the Northwest as soybean history has kind of grown in the province. But there's been 56 trials there so far. For single versus none, 42 trials since we started these in 2016. These have largely been concentrated in central Manitoba still, but there is that there's definitely an opportunity there to move them a little bit westward or to the north as we've got quite a bit more soybean history in some of these fields. But really what these trials are really trying to drive home is will reducing or find an answer to, I should say, is will reducing this input impact soybean nodulation or yield on my farm? There is a minimum field history requirement to participate in either of these trials. We want to see either 2 years of soybeans in that field previously for double versus single, and we want to see 3 years at least for the single versus none, and soybeans within the last 4 years for both of them. Though that is the minimum history requirement for these trials, most of the time we do actually have more soybean history in the field than that. So looking at double versus single here, the pie chart on the left is showing the distribution of trials that have had 2, 3, 4, or 5 or more crops in that field where we're conducting that test. And a third of the time, we're seeing that more field history where we've had 3, 4, or 5 or more crops in that field before we've even had an on-farm test. And then the next one is the frequency of soybeans in that field. So in a lot of these fields, soybeans are being grown in 1 in every 3 years, every other year, or more frequently even than that. Single versus none, that minimum requirement is 3 years, but at 75% of these trials at least, we've actually got more history with 4, 5, or 6 or more crops have already been grown of soybeans within that field. And then again, we are seeing more frequent soybeans than every 4 years where we've got every 1 in 3. So highlighted in orange, that would be those combinations of where we'd be the most likely to see a yield response, or those would maybe be considered the riskiest fields for these trials, just because it's got less soybean crops in the field, so only 2 crops, and it's been the longest amount of time since that last crop in the field. So that's kind of another way to kind of look at this. Getting into the yield results, though, double versus single trials, 95% of the time, that extra in furrow granular inoculant did not affect yield or nodulation. So the 5% of the time where it did, that again was that combination where it had only been 2 previous soybean crops in that field, and the last crop was 4 years ago. So a longer break between, or since soybeans had been in that field. Likely also at those trials, there was something that may have impacted rhizobia survivability over time too, that may have improved the likelihood of that yield response in those few fields. So since we're not really seeing a yield return there, there is definitely an opportunity to save $10 an acre approximately if you've got sufficient soybean field history and go without that granular inoculant. When we're looking at single versus no inoculant trials, 100% of the time so far, that on-seed inoculant, that liquid inoculant, did not improve yield. So we do also have an opportunity here to walk this back, but I would note that most of these single versus none trials have had quite a bit more soybean history than required, with 4, 5, 6 or more crops in that field, and soybeans are being grown pretty frequently at over half of those on-farm trials. It is also a cheaper input cost here, just about $3 an acre, so to keep that in mind as well. But choosing an inoculation strategy for your farm, that begins with your last soybean crop. Start by digging up those soybean roots in July. Are they effectively fixing nitrogen and nodulating well? So we want to see at least 10 active nodules per plant. And by active, I mean they're bright pink inside. That's showing us that they are fixing nitrogen. If you've got that, then you can definitely consider for future crops, if you've got that history as well, to start walking back some of this inoculant. So I'd say use a single inoculant strategy, that liquid on seed alone, in those fields that have had more than 2 well-nodulated soybean crops, or at least 2 well-nodulated soybean crops, and you've got soybeans within the past 4 years, and also no significant flooding or drought has occurred in that field. I will say though, after 56 trials, quite a few of those trial fields have had flooding or drought occur to them, and we're still not seeing those yield responses. So that one you can maybe take with a little bit of a grain of salt. Just think about how severe that flooding or drought was in that field. And then when to actually use that granular inoculant or that double inoculant strategy, always in fields with limited soybean history. We have to introduce this rhizobia into our soil. It's not native here. So if you've got limited soybean history, absolutely use that granular inoculant. Granular inoculant is also going to be a little bit more resilient in the soil. When we've got those dry spring conditions, it will hang around longer than a liquid on seed. And then consider it as well in fields with major flooding, where we might have expected that rhizobia survivability to have been negatively impacted. And then when to use no inoculant at all, well, you don't really need that inoculant if you are growing soybeans every other year in a field. Do keep in mind though that elevated disease risk. If you've got frequent soybeans, be thinking about Phytophthora root rot among other diseases, since there is other risks around that. But if you are growing soybeans that frequently, you likely don't need the inoculant. Biological products is another growing in popularity trial, I would say. So we had eight different trials this year testing different biological products on farm. And there are quite a few different biological products entering the market. And they all have kind of different claims. It might be promoting soil health, plant uptake of nutrients is quite common, all kinds of things. So since we started these trials in 2019, we have had 25 trials in soybeans. So far, for all the different products that we've been testing, we actually haven't seen any yield increases yet for any of these products when we test them at the field scale using replicated and randomized on-farm testing. And these products that we've tested have ranged anywhere from $5 to $30 per acre, and we are not seeing a consistent return on investment to those projects so far, so you can kind of consider that a loss in profit there. These trials will continue as long as there is interest in farmers wanting to test these products on their farm. And I would say testing these on farm is the best course of action. Don't bet every acre on them to start. Dig a little deeper and see if they hold up at the field and in your own farming system. Let's move into peas now. So starting with pea fungicides here. These also take two forms. So 1-app versus none, that's a single foliar fungicide application applied at flowering versus none at all. This is a trial type that we would more commonly test in drier years, where the question is, do we need a fungicide application at all, or can I get by without? Versus 2 apps versus 1, it's not even a question of that first fungicide app. There's the disease risk. It's been a wetter year. And it's more a question of, do I need that second application to carry me through flowering and early potting to protect yield a little bit longer there? Just with the variability in rainfall this past year, it's definitely more of a question of, will that fungicide app pay? And we did have 7 trials in 2023 looking at 1-app versus none. So that's what I'm going to focus on today. But yeah, in 2023, in June, potential trial fields had received anywhere from 23 to 77% of normal rainfall. Digging into those 2023 trials, the products tested were either Dyax, Delaro, or ReviPro. 2 trials this year did actually test 2 products versus none, so Dyax and ReviPro at one and Delaro and ReviPro at another. And then 14 days after application, our diligent field staff were out rating diseases. Here they are getting lost in a pea field, and chances are if your pea crop is thick and luscious enough to actually lose people and staff in, there's a chance you're gonna be seeing that yield return for sure. And yes, this is always a lot of fun navigating yourself through a pea crop when it's this thick. Into those disease ratings though. So Microsphaerella or Ascochyta blight, that does infect every pea field every year in Manitoba. It's just a timing or a matter of what time that infection occurs and how severe it gets in terms of its impact on yield. So classic symptoms of Microsphaerella is lower in the crop canopy towards the soil surface. You'll have these little freckles on pea leaves, or you could have these concentric ring lesions as well, as that disease is also developing too. But typically it is going to be in that lower crop canopy towards the soil surface. You've got to really get in there to see those early symptoms. But in 2023, on average, a single application did reduce the severity of these foliar infections by 19%. Once these get more developed, they can also move in to infect your stems. And we saw a reduction in the number of plants with stem infections by 12% with a fungicide application. And then post-harvest this year, we sent seed samples off for testing to see if a fungicide application had any impact on the amount of seed-borne Ascochyta. Overall, seed-borne Ascochyta was quite low, coming off, I think it was below 3%, well within thresholds. But we did still see a reduction in the amount of seed-borne Ascochyta infections with that single fungicide application. Another form of testing that we took was to test untreated areas of these different pea trials and send them off to the lab. We're looking here to see if the disease is developing resistance to group 11 fungicides. So group 11s are your strobilurin fungicides or strobies. So they could include Acapella, Headline, Quadris. They're also a component of several products like Delaro, Dyax, and others. And what we were finding here is very low levels in the Northwest with as high as 5% resistance towards central Manitoba here. And that is resistance of this pathogen to group 11 fungicides. Getting into yield results now for these 7 trials. Anywhere with a letter separation is where we saw a significant yield increase with that single application at flowering, anywhere from 3 to 13 bushels per acre. These 2 trials at the end are the ones that compared 2 products versus none. And you can see here that there's actually no difference in the products, but both of them are improving yield and reducing disease pressure relative to that untreated peas where there was no fungicide applied. So adding in some economics here, we assuming $10 peas and anywhere from $10 to $20 depending on the product applied. We are seeing a return on investment of anywhere from $20 to $100 an acre at these significant sites. At these other sites where we're not seeing yield response, that is a loss in profit equivalent to the cost of product. And we've got kind of 2 different ranges here depending on if it was kind of a cheaper product versus one of the more premium fungicides applied. And so that's why you're seeing a loss of anywhere from $10 to $20 an acre. And then if you were curious what 110 bushel peas looks like, that's what this background slide has been. It looks a bit like a golf course, but these are peas down by Notre Dame Altamont area that saw that $100 an acre return with a fungicide application. And then looking at this whole data set since 2017, over 32 trials comparing a single application versus none. Again, this has been more common to test during drier years, but we did see a reduction in the severity of foliar infections at 43% of trials, reduction in both the severity and amount of plants with stem infections at 25% of trials, and a yield improvement 31% of the time, on average improving yield by 6 bushels per acre, which adding in those economics is a return of about $40 to $50 per acre on average. But improving yield, 30% of the time, that's not frequent enough to blanket apply a pea fungicide every year. We can definitely fine tune this management decision and apply when we've got that risk. So let's talk a little bit more about that. when to use that fungicide in a dry year. It does start with scouting your crop. So the nice thing with peas is we can look for this disease before we spray. So we can check for these freckling symptoms in the lower canopy in late June and through July and monitor this disease progression within the crop. What we want to do is restrict that infection to the lower third of the plant and prevent those stem infections because that can impact your standability and lodging in your peas. The things we want to consider are crop canopy thickness. Are you losing people in it? The rain forecast and relative humidity within that actual crop canopy. Do you have those conditions for that disease to really take off? Along with these symptoms in your crop canopy. So we do have a fungicide decision worksheet for making this application in peas, and I encourage you to check that out if you're at all curious. It does kind of walk through all these factors a little bit more and make it a little bit more clear cut. Moving to pea seed treatments, this was a new trial in 2023. So there's two different seed treatment kind of trials. The first was fungicide seed treatments to manage root rots, and then the other was insecticide seed treatments specifically to manage pea leaf weevils. Starting with fungicide seed treatments, this background here, those are neighboring pea fields. The field on the left, that's the first time that field has seen peas, whereas the field on the right has pea history and also has quite a rampant root rot infection. Taking a closer look at what those plants look like, we've got yellowing from the base of the plants up. Those roots are also rotted when you pull those plants out of the ground, and they're generally suffering quite poorly. So we do have kind of two main root rots that we'll kind of talk about and target with some of these fungicide seed treatments. So the first being Fusarium species causing root rots. So that is more common on label for fungicide seed treatments. Fusariums do typically infect every pea field every year. But this, again, the severity and timing of that infection is pretty important in terms of its impact on yield. And now we've also got two seed treatments that are available for suppression of Aphanomyces. And the main management tool we otherwise have for managing Aphanomyces is just a longer crop rotation break between pea crops to draw those disease levels down. We're not expecting seed treatments to be a complete solution. There's hope they'll help get that plant established and get those root systems developed before infection takes off from these root diseases, because Fusarium and Aphanomyces, they typically prefer warm, moist soils, so we'll see these infections move in after a nice warm June rain a lot of times. So the hope here is that these fungicide seed treatments might be a tool we can add to other management tools to help get these plants established and better tolerate infection. So we did have two on-farm trials testing fungicide seed treatments in peas in 2023. One tested Rancona Trio, which has activity or suppression of Aphanomyces, and the other tested both Rancona Trio and Trilix Evergoal. So we did see a reduction in the percent of plants infected with a root rot by 10 to 20%, and we also saw a reduction in the severity of those root rot infections. Although overall it was quite dry, so the severity was pretty low for these root rot infections. Here's an example photo from one of those trials. We did not see a significant yield effect here, but there is potential here. You can see that in that disease reduction, where this is pretty early days for this trial type, but as a part of a larger strategy, there is potential here that we'd like to look into a bit further. But since we didn't see those yield responses, that does mean we had an overall loss in profit, anywhere from -$5 to $17 per acre, just depending on the seed treatment you're using and the seeding rate for how many bushels of peas you do have to treat. Now talking about insecticide seed treatments, specifically regarding the pea leaf weevil. So these adult pea leaf weevils notch the edges of pea leaves. That's how you know they've been there, because these are actually quite small. You wouldn't be expected to kind of spot those too easily, but if you've been noticing your pea leaf edges have become a bit more jagged, chances are it's from this guy here. These adult weevils don't actually cause any yield loss, but once they've been feeding on their host crops, peas and faba beans, they're laying eggs, and those eggs are hatching, and the larvae are burrowing below ground into your root nodules on your pea plants and hollowing those out. So the mechanism of yield loss here is from these larvae, where they're robbing the plant of all of their nitrogen fixation benefits. So there are foliar sprays available for pea leaf weevil, but they're not expected to be effective because once you've once these adult weevils have reached their threshold levels, they've already laid eggs. That damage has already been done because those eggs are going to hatch. That larvae is going to move into your root nodules. So we don't consider those foliar sprays to be effective, whereas the insecticide seed treatments from the literature do have a bit more potential, and that's why we want to investigate them on farm. The other reason we should care about this pest here in Manitoba, since it is a newer pest, we started surveying it formally in 2022, where we found higher levels in northwestern Manitoba with some presence of them in just southwestern Manitoba. And then in 2023, when we repeated this survey in the spring, we're seeing much higher levels in the northwest, and we're also seeing them move eastward into central Manitoba. So we have range expansion along with a population increase. So we did have one on-farm trial in 2023 comparing imidacloprid seed treatment versus untreated peas, and there was also 2 small plot trials that compared all available insecticide seed treatments near Roblin and Swan River. So in year 1, there was no significant impact of seed treatment on pea yield for either the small plots or the on-farm network trial, but we did see a decrease in predation with a cruiser seed treatment at Swan River, where the amount of these notches on leaf edges were reduced by 42% with that seed treatment. So here again, this is still early days. We do want to follow these through for a few more years, get some confidence in these results, but here's a sneak peek at where we're at with some of these seed treatments so far. Since we didn't see that significant impact on yield, we do see a loss in profit of about $10 per acre, depending again on your seed treatment and amount of seed you're treating. Looking at pea seeding rates very quickly. So started these in 2021. Typically, we do have 3 seeding rates tested here as well, just like with soybeans. So that's the farmer's normal seeding rate, plus or minus about 40 pounds per acre, which is equivalent to roughly 80,000 seeds per acre. So 2 trials in 2023 and 8 trials overall for these. Just visually comparing kind of one of these lower seeding rates to a higher seeding rate, you can see just how much better these pea plants are able to knit together when there's more of them in the field versus something where there's a bit more open here. But when we look at yield response, so each grouping of colored dots is a different on-farm trial testing three seeding rates. These are the living plant stems and the yield that emerged. So across a pretty wide range of plant stands within each trial, it's just a series of flat lines. There's really not a yield to plant stand relationship emerging here. There have been no significant yield responses to seeding rate treatment so far for these pea seed treatment trials. Highlighted in between 7 and 8 here, that is your target plant stand for peas, which is quite interesting since we are following quite a bit lower than this target plant stand, but we're still seeing pretty good yields across the board with these lower plant stands. So this is something we're looking to continue in the future, really dive into this a bit more because it's something that we've been thinking about quite a bit. We were noticing this in our pea fungicide trials originally when we were taking plant counts and comparing it to yield, where we were really seeing plant stands kind of all over the place for peas. So that's why we started to formally investigate this in 2021. And since we're not seeing that yield response, we do see a loss in profit equivalent to that increased seed cost of about $20 per acre for each 40 pounds per acre increase in your seeding rate. Now moving into dry beans. So 2023 isn't the first year we've tested dry bean inoculants, but there were 4 trials this year, so I would call it a bit of a resurgence in investigating dry bean inoculants. Whole purpose here is just, can we get this crop that we traditionally fertilize, can we get it better at fixing its own nitrogen? Because they are nitrogen fixers, it's just that they don't do a fantastic job of it. So we have been supplementing them with nitrogen. So we've had 4 trials in 2023 in navy, black, and kidney beans. We tested Egg to Fuel or Thrive, and there were no significant differences in either nodulation or yield in these trials in 2023. As a result, we're seeing a loss of anywhere from $5 per acre for the fuel alone, or $18 per acre for Egg to Thrive, which has a mycorrhizal product built into it that to improve kind of that nutrient uptake. So I guess you could call that a bit of a biological product add-in. The other part with the driving inoculant trials this year is there is research happening at the University of Manitoba, along with other research collaborators, where they're looking to develop an effective inoculant for dry beans. And the way they're doing this is from isolating strains of rhizobia that are already forming nodules with our dry beans crops from Manitoba and Ontario soils. So what we did in some of these on-farm trials, along with a bunch of other dry bean fields in 2023, we collected soils from those fields, sent them to the lab, and they've already isolated more than 200 rhizobia strains. And this research is in progress, but there is a lot of potential here to develop an effective inoculant for dry beans using rhizobia grown in our own soils that are already adapted to our climate. So very excited to keep this research in mind moving forward. Other dry bean trials, we did also test nitrogen rates in 2023, as well as fungicide applications. And we are going to talk a little bit more about these at our dry bean meetings on February 8th and 9th in Portage la Prairie and Altona. So please do stay tuned for those meetings where we hope to dive into these a little bit more. And if you're not able to make either of those, they will also be posted on our Manitoba Pulse Growers YouTube channel for viewing at your leisure. So thanks for your time today. I've been Laura. If you do have more questions or trial ideas for future years, please do contact Chris Forsyth. He's our on-farm network agronomist. And again, if you do want to explore any of this data a little bit further, please visit our on-farm network results database. The QR code here is in the corner.